Hello friends, today I will discuss linear differential equation of second order. In my previous video I have discussed about linear differential equation of first order and its some types of linear differential equation of first order. So in this today's video I will discuss about linear differential equation of second order. So let's start discussion about it. If you are given a linear differential equation such that d2y by dx square plus p dy by dx plus q equals 0. So this kind of equation is called as linear homogeneous. Homogeneous, why homogeneous? Homogeneous means here at the right hand side you are getting 0. So this kind of equation is linear homogeneous second order differential equation. So now I am going to discuss how to solve this kind of equation. So d2y by dx square plus p dy by dx plus q equals 0. So this kind of equation is linear homogeneous second order differential equation. So now how to solve this? So let's start the discussion of solution. So to solve this, first you have to assume ddx equals m. Say ddx equals m. So d2 by dx square equals m square. Now after assuming this, you have to do so first step is it is step 1. Step 1 is assume ddx equals m. So d2 by dx square equals m square. It is a step 1. And what is the second step? After assuming this, just write auxiliary equation. Auxiliary equation. Second step is write that differential equation in terms of auxiliary equation, that is m squared d2y by dx square you know plus pm plus q equals 0. So this is the second step of writing auxiliary equation. It is step 2. Step 1 is what? Step 1 is assume m equals ddx and m square equals d2y by dx square. And second step is what? Second step is m square plus pm plus q equals 0. Now from the equation m square plus pm plus q equals 0, from here you will get two roots, m1 and m2. You will get two roots. So after solving and factorizing this equation m square plus pm plus q equals 0, you will get two roots, that is m1 and m2. Now different cases comes. So solution of linear differential equation actually consisting two things. One is complementary function CF, another is particular integral. Particular integral plus complementary function. So whenever you will solve homogeneous linear homogeneous differential equation, then only solution for linear differential equation will be complementary function. But whenever inhomogeneous equation will come, then particular integral and complementary function both will come. Now you have got two roots. After solving m square plus pm plus q equals 0, factorizing it, if you have got two roots, m1 and m2. So now different cases come. Case 1 is if m1 and m2 are real but not equal. If m1 and m2, these two roots are real but not equal, then what is the solution? As it is a linear differential equation of homogeneous linear differential equation, so you will get only complementary function. So if m1 and m2 are real but not equal, then the solution will be c1 m1x y equals c1 m1x plus c2 e to the power m2x. This is the first kind. And when this is applicable, if m1 and m2 real but not equal. Now the second case is such that case 2. Second case is such that if M1 and M2, if M1 and M2 are real but equal, real roots but equal, then what will be the solution of that differential equation? Then the solution of differential equation will be y equals, as it is linear homogeneous differential equation, so you can write complementary function. Here no particular integral it will be included, because whenever you are writing homogeneous linear differential equation, only complementary function is there, but when it is inhomogeneous, then particular integral will also come. I will discuss that briefly. So when M1 and M2 roots are real but equal, whenever these cases are coming, so then what will be the complementary function or solution of linear differential equation? So if m square plus pm plus q equals 0, m1 and m2 to real and equal root, then solution will be c1 plus c2 e to the power c1 plus c2 x e to the power mx, as m1 equals 0, m1 equals m2 equals m, both are equal, so say m1 equals m2 equals m. So now the third case is coming. Third case is what? Case 3. Case 3 is if m1 and m2 both are complex number. If m1 and m2, these both roots are complex number, then how to solve this? If m1 and m2 both are complex number, then same thing is coming. Same thing is coming means what? Then you can write. So before you writing the solution, first of all, I am telling you what complex number means. What complex number means? If m1 is such that alpha plus I beta, and m2 is such that alpha minus I beta, this kind of case is coming. I is what here? I is imaginary. So this is complex number, na? I is imaginary. So in that case, if m1 equals alpha plus I beta and m2 equals alpha minus I beta, then solution or complementary function will be what? Then solution or complementary function you will write y equals, or CF equals, e to the power alpha x c1 cos beta x plus c2 sin beta x, where c1 and c2 for each case are constants. Here you can take any values. Next case, maybe case 5 or case 6, whatever. If case 5 is such that if m1 equals alpha plus beta, m2 equals alpha minus beta, if such cases are coming, then complementary function will be y equals, not I is given here, I is imaginary number, I is not here, y equals c to the power alpha x c1 cos hyperbolic beta x plus c2 sin hyperbolic, let me write another slide, y1 equals c1, y1 equals e to the power alpha x c1 cos hyperbolic beta x plus c2 sin hyperbolic beta x. When this case will come, if m1 root equals alpha plus beta and m2 root equals alpha minus beta, such cases are coming. So now I am going to take an example. From the example you will be cleared. If a differential equation is such that d2y by dx square minus 3 dy by dx plus 2y equals 0. If such cases are coming, so first step is what? So do stepwise. First step, step 1, assume m equals d dx, and so m square equals d2 by dx square. So what you can write? d2y by dx square minus 3 dy by dx plus 2y. So after assuming that, first second step is what? Write auxiliary equation. Auxiliary equation is what? M square, as m square equals d2 by dx square, and ddx minus 3m plus 2. This is auxiliary equation. This is the second step. So after writing this auxiliary equation, what is the third step? Third step is solve this auxiliary equation. We can factorize this auxiliary equation. M square minus 3m plus 2 equals 0. M square minus 3m plus 2 equals 0. You can write m square minus 2m minus m plus 2 equals 0, or m into m minus 2 minus 1 into m minus 2. However, so we are getting, after factorizing this auxiliary equation, m square minus 3m plus 2. After factorizing, we are getting m minus 2 into m minus 1. This equation we are getting. So we are getting two roots. Two roots are what? M equals 2 and m equals 1. So now the step 3 will come. Step 3 is what? We are getting two roots. M equals 2 and m equals 1. So these roots are what? Real. 1 and 2 real numbers, na? And not equal. Real and not equal. So what case? So case 1 is coming. So complementary function will be what? So complementary function will be y equals c1. Cf means complementary function. c1 e to the power mx means 2x m1x plus c2 e to the power x. So this is the solution we are getting after solving this. So in such a way, if I am taking another example, so you will get, if we write d2x, but here we will take different dependent and independent variable. If we take such case, now here remember, here dependent variable is what? When we are taking d2y by dx squared, there dependent variable was y, but now dependent variable is x and independent variable is t. So first, after assuming m equals, first step assuming m equals ddx and m square equals d2 by dx square, here we can, what we can assume? We can assume ddt equals m and d2 by dt square equals m square. So after assuming this, we can write auxiliary equation m square plus 2m plus 1 equals 0. So two roots we are getting, minus 1, minus 1. After solving this equation, we are getting m plus 1 whole square equals 0. So m equals minus 1 and minus 1. Now both are real, but both are equal. Real but equal. So for real but equal, which case will come? Case 2, x equals c1 plus c2t into exponential minus t. So these are the case. In such a way, we will discuss linear differential second order homogeneous differential equation. We will discuss more about this linear second order homogeneous differential equation. After that, we will discuss linear inhomogeneous differential equation. But for the time being, thank you. Bye. Thank you for watching.